Hello. So again, I have a package arrived from China with this another questionable USB charger, which I have procured off of AliExpress again. I thought we would take a look at it today. This one cost about twice as much as the last one did, so hopefully it'll be a little bit better. Came, as I said, came from China, cost about £1 in this lovely crinkly bag, so we'll get out of that and have a quick look and see what we've got. 2 ports on the top, EU plug on the bottom, markings. Can I get the markings in focus? I just messed with the autofocus settings on this, so hopefully... Oh, there we go, perfect. 2 USB charger, model KKF5. Input is universal mains, output is 5 volts, 2.1 amps. The standard double insulated. It doesn't have any CE marking, UKCA marking, anything like that. It doesn't have any of that, and no other markings on it. It's got a like shrink wrap film. Let's see if I can. Get that off. Okay, there we go. That's the full unboxing experience of what I'm sure is a high quality product. Let's get with testing this, so give me one moment please while I grab the stuff, set up another camera angle to be able to film the testers and stuff, and yeah, we'll see how bad this one is. Okay, so after a few attempts at this, I have discovered something. The European plug on this, sorry, I can't fit in the camera because I have to zoom in, but anyway, it's fake, it doesn't fit. I've tried it in several adapters, it just won't fit any of them. The pins are so small that the spring on the pins, which is supposed to hold them in place, just can't grasp them, so it just falls out all the time. And I was sitting there banging things, knocking things over, trying to work around the camera to do it, so I'm doing it. You can probably see these jumper cables here are attached to the plug pins, and I'm just doing it that way because that's the easiest for a quick test like this. So if I get my thing onto the screw here, because I can't get in without unscrewing the display, and ooh, wrong way, it's alright, I'll start turning up. 200 milliamps, it's already surpassed the previous one. We'll keep going. This said 2 point something amps, I think, was the rating it quoted. 2 amps-ish. So we're just coming up 750, 800, 900 milliamps, 1 amp, and the voltage is still holding at 5.1. We'll keep going. 1.2, 1.3. Oh, there we go, it's dropping off now. So back that. There we go. So 1.3 amps is about the maximum that this can supply. Just under 7 watts there. What I'm going to do is I'm going to leave this under load, and I'm going to see how hot it gets. So I'm going to come back either if something interesting happens or when I get bored. Okay, I'll just come back over again because something interesting is happening now. After probably 10 minutes, I want to say, 10-15 minutes, I haven't been keeping track, probably should have been. But you can see it's now started power cycling. Yeah, not good. It must be overheat protection. If I feel that's warm, wouldn't say it's hot, but yeah. It'll be interesting to get a look at the board then and see what that's like. Okay, on with some more testing. I want to do some insulation tests and stuff on this, and see if we'll pass them. I have an even higher voltage power supply to hopefully get us some more spectacular arcing than last time. So yeah, on with that. Okay, I have the charger there, the charger connected into this in a very dodgy manner. The adapter, it just will not fit in the adapter. I can't get it to make a good connection. So the insulation testing I'm going to do with another box, because I don't want to use this more than I have to in this questionable manner. I don't have anything else that can do the leakage testing though, so we'll run that now. Start, and it will run. Okay, yes. And we'll see, okay, again, fairly low. This, I assume, means it probably doesn't have a noise suppression capacitor, given it is this low. But we'll find that out when I open it. Okay, let's go do the insulation testing now. One moment. Just quickly to confirm this, I just thought I should add this in. I've run another version of the leakage testing because I was quite surprised it was so low, and it's also come out low. So, yeah, we'll have a look at the insides, but I just thought I would show you the results of that as well. Okay, I now have it on the insulation testing rig, or box, which just has clips on it, which is easier than faffing around with that dodginess with the plug and the clips on the end of it. Anyway, so, bump the camera. We've got it set to 250 volts, so we'll do that. And nothing. Set it to 500 volts. Just about, whatever that is, just in between 2000 and 5000 megohms. And then we'll set it up all the way to 1000 volts, and that's like, well, times 2, just under 2000 megohms. So again, it's passed all of those perfectly fine. Okay. Again, I'm quite surprised that they're so high. There must not be an insulation capacitor or anything in there. I'm going to now open this, and then after we've opened it, I have a couple more tests. I want to scope the output of this actually. The last one I was setting after I'd done it, and like, oh, I should have looked for the ripple on the output, so we'll do that. Although I want to open this so I can solder wires onto the like transformer secondary and the output and all stuff. You'll see. So I'll clear this out of the way, and then we'll look at opening this. Okay, now for the small matter of opening this, I suspect this might involve force and tools. It's not going to be as easy as the other one. I can't tell exactly where this opens. I don't know if you can see if it will focus. Focus? Maybe it will. But there's a slight lip here. So it might be this top bit comes off, but I don't think it does. I think that around here probably this bottom part comes off, but it will not budge. So I've got a screwdriver, and we'll just try and see if I can push it in to the thing with it. No, we can't. Yeah, I'm just going to stop faff with this, and I'm going to cut it open. One moment while I go find something to do that with. Okay, I have set this up. It's a bit of a mess with wires, but I'll explain quickly what's going on. We have coming in here, I'm not going to touch on this because it's all live. I've been testing things to make sure that it worked properly before I hit record. We have the mains comes in here. This is the power supply. Then we have the standard meter and test load. These wires here I soldered onto the bottom of it, which go to my probes on my oscilloscope. Channel 1 on the oscilloscope, which is the yellow trace, which should hopefully appear here somewhere. The yellow trace is channel 1, that is connected to the secondary winding of the transformer, so you should see the AC waveform on that. And channel 2 is connected to the DC on the output, so we can hopefully see the waveforms on that and see how much ripple there is when the load is increased. So I'm going to turn the power supply on, and hopefully we should get readings on the scope. Oh yes, and we do. So you can see the pulsing on the yellow trace, that's the secondary, and the... Hold on, let's see if I turn this light off, can you read the display better? Oh yeah, you can, that's great. So you can read the numbers on the USB meter. I'm going to then start gently turning up the load, oh, wrong way, turn the load up, and you can see as I increase the load, the pulses on the secondary transformer are getting closer together because it's having to put more energy through. So let's just quickly adjust the settings on the oscilloscope. Oh, no, wrong way. To zoom in a bit more, so you can see the waveform. Maybe slightly more than that again, so we can get a better look at it. You can see the nice waveform there, the pulse, and then the oscillations. So we'll keep turning that up, and you can see they keep getting closer and closer together. The voltage on the green trace, you can see we still have a lovely smooth DC. That's exactly what it should look like. And you see the pulses on the secondary getting closer and closer as it has to force more and more through in order to keep the voltage on the output high. It has to put more in. And keep turning it up, just passing 1 amp there. So it goes up to 1.3 amps, if you remember from earlier. 1.3 amps before it will overheat, or sorry, before it will start to drop off. Again, if I put the time base down even more, you can see now the waveforms have gone because this oscilloscope doesn't actually go down as far as the software will let it, because it's not the top range model. Keep turning that up. This is actually quite surprising. There we go. So if we turn it, there we go. So 1.325 amps, we have lovely DC. We turn it up to 1. That's when the voltage starts to drop there, so just over 1.3 amps. You can see the lovely DC voltage starts to drop, and it turns into a ripply mess, and it's no longer a nice DC. It's not actually that bad. I was expecting it to be worse. You can probably hear the cooling fan has kicked in on the thing. And I'm going to keep cranking this up and see if anything interesting happens. The voltage is falling, which is not surprising, but we're seeing very little change on the scope now, other than the output voltage is dropping, and there's some slight ripple on it, but nowhere near as much as I was expecting. Okay. Well, that was quite interesting. I wish I'd done that with the previous one, because I think it would have been quite interesting. The smoothing capacitor on that was fairly small, if I remember correctly. Yeah, let's move on to the next part, where I'm going to have a look at the schematic of this, and then I'm going to do a very high voltage test on it with my new power supply. And I think that's everything, so one moment while I do the schematic, yeah, I'll be back in a bit. Okay, schematic drawn. This is a bit hard for you to read the stuff at the top here, so I am going to take a scan of this and put that on the screen now. And after you've managed to have a look at it, I'm going to now explain here. Up here, first we have line of neutral comes in. It's a non-polar plug, but I've just labelled them as that because, well, that's how you'd normally do it. Again, we have, if I can get you there, another fake fuse. What a surprise! And this time we have an actual full bridge rectifier, which is nice. We don't usually see those. Well, in the really crap ones, we don't usually see those. And anything of half decent quality you'd expect to, which is that little 4-pin chip there. That then comes out smoothing capacitor, which is this one here, 400 volt smoothing capacitor, 1 microfarad. We then have this winding here is the primary on the switching transformer. This chip here, 3773CL, I have not actually googled that or looked it up. I'm not sure, it's probably some sort of switch mode driver standardish thing. That is, again, there we go, this 8-pin package, although only, well, it would be a normal 8-pin package, but some of them are missing. You can see, hold on, hold it back in again here. you can see the missing pins between these two here to provide additional separation, and these pins are combined to allow higher current flow. So only 4 of the pins on this chip, because another couple of them just don't connect to anything. They have... Sorry, I'm going to zoom in and out on this and post a lot jumpy back and forth probably, but there are missing resistor positions here, which is to connect the other pin which doesn't go anywhere. So we have, yeah, the primary goes into that and is then switched to ground, or sorry, not ground, to the 0 volt rail. There is then, this is the feedback winding, and this is how it must be doing the voltage regulation, because there's nothing to feedback from this side here. It would appear these two are forming some sort of voltage divider network, and it's then using this here, which is effectively the midpoint of these, to give it a voltage across this. And we have here the smoothing capacitor. Strange thing, there is no diode, which I suspect this capacitor is probably going to explode fairly quickly in operation, because there's a place where the diode is supposed to be. It is supposed to be here, and it just isn't. Actually, no, it is connected. It's connected, yeah. I was going to say it might not actually be connected to anything, but no, there is a track. It connects back into the chip, into this point here. So this is going to be basically being charged with AC, so it's going to blow up really fast. I don't know what on earth they're thinking with this. Who knows? It's a crap charger. I'm not surprised. And that's basically it on the primary side. As I mentioned previously, there is no noise suppression capacitor between here and here. That's where it would go if there was one. We then have on the secondary, I'll move this so you can get a better look. On the secondary side, secondary winding, just a standard diode. I checked this one this time, I checked them all. Standard diode, we have a 470 microfarad smoothing cap on the output, 1k load resistor, and then a 1k resistor with the white LED, and the USB port with all 4 data pins commoned. Again, you can see that on the circuit board. We have, these are the positive, these are the negative, and those are the 4 data pins, which are just coupled together. I think that's everything. I can't think of anything else to say about this. Again, fairly minimalist. It uses this chip to do basically everything. It's quite impressive how well it can regulate the output voltage just based off the feedback winding here. That's quite clever. But I can't think of anything else to say, but this is fairly simplistic. And as I said, the lack of diode here is strange. But yeah, it's strange. I don't really know what more to say about that than it's just a bit odd. Okay, now to obliterate this with high voltage. Okay, this is the final test before I take the transformer apart, and then we're basically done with this. I can't think of anything else to do. I have my brand new 12,000 volt direct current power supply, 12,000 volts DC attached. I've soldered the leads on because I haven't put anything on the end of it. This is how it came from the factory, and I've not touched it yet. I haven't actually powered it on yet because there's a slight discrepancy on the listing was 220 volts. The sticker on the box says 220 volts, but then there's another sticker which says 1.5 volt. And I've looked inside it, and I'm pretty sure it's 220 volt, but it might be 1.5 volts, so I decided to have the camera on. Might even... no, I'm not. I'm going to leave it trained on this, because this is where the excitement's going to happen, most likely. But it might explode rather spectacularly, so I figured you all would want to see that if and when it happened. So I'm going to turn on the power supply, and we should hopefully see some arcing somewhere. So 3, 2, 1. Interesting. It actually seems like it might have passed. How strange. I can't hear arcing. That's a bit anticlimactic. Oh well. Let's take the transformer off it then and have a look at that. Boring. I mean, honestly, I wanted some smoke or something. Jeez. Yeah. Bloody hell. I'll just, maybe get a big bang when I do this. No, nothing. Hold on, I'm going to check this press plate actually works. Okay, so it definitely has failed somewhere. When I was deciding to test this, I thought, I know, let's just desolder that and see if it arcs anywhere. And it would seem it had failed entirely, it just wasn't making any noise. Because have a look at this. Yeah, definitely failed. Okay, I wonder if it's tracking through. I was expecting it. Where's some VDE, something I can poke with? I was expecting it to just arc through here, but I guess it must have punched straight through the insulation side of the transformer again. And also that arc, I don't think is DC. I think that they're full of bollocks when I say it's DC, because that sounded like an AC arc. It might have been a square wave. Pulse square wave DC. I don't know. Anyway, it didn't sound quite right. But yeah, it definitely failed. Okay, right, let's have a look inside the transformer and see if we can tell where and why. I figured when we're taking the transformer to this, let's have a play with the new toy. The video of me dealing with this won't have come out yet, I don't think. But basically I have a video where I cut the plug off it and put a compliant plug on it and did some safety testing on it. Anyway, I have a desoldering gun now. Oh Christ, it stinks. You can see here, but yes, magic smoke is coming out of it when I actuate it. So I'm going to let this sit and burn itself in for a while and burn off all the crap inside, and then we'll take the transformer out. Or I probably won't even film myself taking the transformer out. I'll take the transformer out and then we'll have a look at it together. Okay, I have the transformer core here. I'm going to try and zoom in a bit more in post, but unfortunately there's not much I can do without a proper macro lens. I figured I'd film taking this one apart though, so you can see the joys or the potential horrors with me. The tape, oh, I'm already going out of frame there. The tape, or the isolation on the outside, this, no wonder it was arcing through. Oh, this is a joy. Okay, sorry, I'm trying to stay in the middle of the frame, but it's probably going outside all the time because it's going to be a really small area I'm trying to work in. I don't know if you can see, but what? There is no isolation inside this at all. No wonder it was arcing over, because there's literally nothing. All the windings are directly on top of each other. This is disastrous. Okay, so everything I said about how this one might be decent goes completely out the window. This is probably one of the worst ones we've seen. This is arguably worse than the one yesterday with a 1mm separation distance. In this case, the only thing isolating you from the mains would be basically a layer of paint. And I don't know if all of you are different, but if someone said to me, oh yeah, touch this live bus bar, don't worry, I've painted it, I wouldn't do it. I doubt you would either, and that's effectively what you're doing with this. I'm honestly really quite shocked that it passed the insulation resistance testing. I would have expected that the standard 1000 volt or 500 volt would have blasted straight through that, but it didn't. I'm going to get some close-up pictures of this with my macro camera to see if I can show you them. I have another camera which is not capable of doing video, which has much better macro. So I'll take some pictures to show you what I'm seeing, and bloomin' hell, is that bad? Okay, one moment. Okay, so I've taken some pictures with the macro camera, and I've unwound some of it, and you can see there is actually some isolation. But what's happened is, so they have the feedback winding wound on top of the secondary, and then a layer of isolation wound on top of the primary. But that's pointless, because as you can see from my schematic, if we zoom back out, the feedback winding is on the primary side. So, yeah, it's completely pointless having no isolation between here and here, but isolation here and here, because it's not that, it's going to be the weak point. If you were going to have anything with no isolation between it, and this is still bad, but if you're going to have anything having the feedback winding with no isolation to the primary, would be probably not risking anyone's lives. But, gee, that's bad. That's like really bad. Having nothing between the secondary and the feedback winding. Yeah. And there is tape, but it's got big gaps around it too. I don't know if you can see that. I took a picture with the macro camera too. But the tape has got huge gaps at the top and at the bottom. It might as well not even be there. This is probably one of, if not the worst, switching transformer I've ever taken apart. Okay, now we've done that, let's go do the conclusion. So, to conclude, this seemed kind of decent at the start. It kind of looked okay. But then as soon as I took that transformer apart, this thing is a complete death trap. It is worse than the previous one by a substantial margin. This thing would put using this to charge your phone would put your life at risk. Do not risk it. This is why I say do not buy cheap chargers from eBay or AliExpress or Amazon or anywhere, because you don't know what you're going to get. You could get something like this, which is literally only thing isolating you from mains is a layer of paint. Or it could be fine, but it might not be. And do you seriously want to take that risk for only saving yourself a few quid? It's not worth it. Just don't. This is a complete death trap. Yeah, I have another charger from the same supplier, which was equally very cheap, which I'm going to take a look at later. That's going to be fun. Yeah, let's hope that that one's not quite as disastrous as this, but it probably is going to be. Yeah, really, I don't know what much more I can say. The schematic and everything is fine. This would probably be kind of semi-passable if it just had a half-decent transformer in it. But the fact that the transformer is crap means that the whole thing is a death trap. Yeah. Thank you so much for watching. Remember to like, share, subscribe, do those things. And I will see you in the next video, which will probably be the one about that desoldering thing. I haven't actually bothered to edit that one yet, although I want to get this one out faster now, because this is really quite an exciting one with the disastrous transformer. So, yeah, I'll see you in the next video. This is an aside, I'm probably going to put this on the end after the outro of this video. But last week I was a bit confused because I was expecting there to be quite a lot of burning inside, and there wasn't. And I was speaking to people and it turns out that's because the RF doesn't burn things, blah blah blah. This is definitely RF. I had another look at the circuitry inside it. It's definitely not DC output. I'm very annoyed. I want a DC power supply. I'm going to have to buy another one. But if you look at this, you can see it doesn't burn things. Like, for example, if I turn this here, you'll see it's arcing straight into the side of the board. I'm going to let this go for ages. And if we have a look, no burning, no char marks, nothing. There's just a slight divot where it punched through the solder resist. So, Yeah, makes sense as to why there was no burning inside the transformer last time. Anyway, yeah, thank you for watching, and see you later.